In the series Advanced Mathematics, we are going to start the lecture 5 of chapter Vector Calculus, and in this lecture we will discuss about some basic facts related to the integral calculus of the vector valued functions. So first we are going to look at the definition of how the integral of a vector value function is defined. So we are saying if we have two functions, this is f vector t and f vector t are two vector functions of the scalar variable t such that d by dt of f vector t dt that is equal to f vector t, then this function capital F vector t is called indefinite integral of the function ft with respect to t, and we can write it is integral of f vector t that is dt that is equal to f vector t plus c vector, where this is the constant of integration. Now we are saying that if we have the function that is defined in this way, it is f vector t dt we are saying, and the components of this function f vector t, they are f1 vector t, this is I cap dt, plus j cap integral f2 vector t dt plus k cap integral f3 vector t dt. So we are saying that if we want to integrate a function, we can integrate that function component wise. Next we have is the definition of the line integral. So let we are saying that we have a function, it is f vector, it is a function of x, y, z, and a b be an arc of a curve. The line integral of f vector along curve AB is defined as the integral of projection of f vector. This is the definition we have. It is the integral of f projection of f vector along the tangent to the curve AB. So we are considering a curve. We are saying suppose this is the curve, this is AB, and this is the arc AB on it. Suppose we are talking about the tangent at this point, and the function f vector, this is the vector we are saying, this is f vector that we have. So projection of f vector along tangent at point P on AB, this is the point P. So projection of this vector we are shifting to this point, this is the vector we are seeing. So the projection of this vector will be in this form on this tangent, and its value will be given by the f vector, this is f vector, this is t cap, this is the direction of tangent. So we are writing this is equal to f vector dot t cap, and t cap it is given by dr vector by ds. So we are saying the line integral, it is defined as integration over c is representing this curve, it is f vector dot dr vector by ds into ds. We are considering small portions over here, and these portions, these are the arc length ds we are saying. So this value is equal to integral over c f vector dot dr vector. This is the line integral we are talking about. Now if the components of this f vector, they are f1 I cap, f2 j cap, f3 k cap, then we are writing f vector dot dr vector that is equal to f1 dx plus f2 dy plus f3 dz, and the line integral of this, the line integral over c, it is given by integration of all these terms over c. So we can write, if f is a function of, if this x, y, z, these are further the function of t, we can write this is equal to integration over c f1 dx by dt plus f2 dy by dt plus f3 dz by dt, and integral with respect to dt. So this is the definition of line integral that we have. Next is vector line integral. So if we replace the dot product by a cross product, in the previous definition, why we were having dot product? Because we are talking about the projection. So we are obtaining over here, it is f vector dot t cap. Now if we replace this dot product with the cross product, then the integral that we obtain, it is called vector line integral. This is the definition. We are saying the vector line integral, that is equal to integration over c f vector cross dr vector. Next definition we have, it is circulation. So if c is a closed curve, then the tangent line integral of the vector function f vector xyz around c is called circulation of f vector, and it is denoted by this c. This is representing the circulation, that it is the closed curve on which we are talking about the integral. And if the value of the circulation, if the value of this circulation is equal to 0, then the field f vector is conservative, or we are saying it is an irrotational field. So if we talk about the example over here, we are saying if f vector represents the variable force acting on a particle along arc AB, then the work done, we are saying suppose there is an arc AB and force acting, this force is acting on the particle which is moving along this arc AB. So the work done in moving a particle from A to B along this arc, the particle, it has started from here, the force is being applied and it reaches the point B, then the total work done, it is given by integration A to B f vector dot dr vector. That is, this is a line integral along this arc. If f vector is irrotational, then the line integral of f vector from A to B does not depend upon path. It means we are saying that if an object starts moving from this point, say this is the point A, it moves like this and finally reaches the point A, then we are talking about the closed integral on this C. We are talking about f dot dr vector, and if this value we are saying it is equal to 0, if we are talking about the work done, we are saying this will be equal to 0. So we are saying in this case f vector is irrotational, or we are saying it is conservative force. Now previously we have also studied this term irrotational, and we know that f vector is irrotational. F vector is irrotational if curl of f vector is 0, and this implies us there exists a function phi such that f vector is equal to gradient of phi. We are talking about the scalar potential. So now what we have is that if we are taking the line integral along this whole closed curve C, then the value we have, it is equal to 0. Now suppose we are saying that any object, it is being given that f is irrotational. We are saying any object, it is moving from point A to some point B on this curve. So in that case, the work done will be given by A to B f vector dot dr vector. We are writing this is A to B. In place of f vector, we can write del phi dot dr vector. This is equal to integration A to B curly phi by curly x into dx plus curly phi by curly y into dy plus curly phi by curly z into dz, and we are saying this is equal to integration A to B d phi, and the answer we get, that is equal to phi b minus phi a. So we are saying that the line integral, that is the work done from moving the particle from A to B, it depends upon the potential at B and potential at A, the scalar potential at B and scalar potential at A, and it does not depend upon the path. So what we have obtained, that if f vector is irrotational, then we are saying it does not depend upon the work done by it does not depend upon the path. So if we are not using the term work done, we are saying if any field that is given to us, a vector that is given to a vector is irrotational, then the line integral that we have, it does not depend upon the path. Now next we have to evaluate the line integral. It is integration y plus z over x ds, where c is the arc of the circle x square plus y square is equal to 4, z is equal to 0, and from this point to this point in counterclockwise direction. So we know that we have already seen in our first lecture that the equation of this circle x square plus y square is equal to 4, z is equal to 0, it can be written in the parametric form as x is equal to 2 cos t, y is equal to 2 sin t, z is given to be 0, and t is varying from 0 to 2 pi. T is varying from 0 to 2 pi. And the value of ds by dt, the arc length, we know the formula, it is square root of dx by dt square plus dy by dt square. So the answer we are getting over here, it is square root of dx by dt. This will give us 4 sin square t plus 4 cos square t. So answer we get that is equal to 2. Now look at this figure over here. We are talking about a circle like this. It is in the xy plane. This point we have, it is 2 0 0, and second point we have, it is root 2 0. Somewhere over it is square root 2 and 0, and this t basically represents the angle this line makes with the x-axis. So we are saying corresponding to this point, the value of t we have, it is equal to 0, and corresponding to this point, the value of t we have, that is equal to pi by 4. This thing you can also obtain from these two results. We are saying when x is equal to 2, y is equal to 0, we are having cos t is equal to 1, sin t is equal to 0. So the value of t we obtain, that is equal to 0. In the second case, we have x is equal to root 2, y is equal to root 2. So what we obtain from this is that cos t is equal to sin t is equal to 1 by root 2. So the value of t we have, that is equal to pi by 4. Now we have to find the integral. It is y plus z by x into ds. This is over c. So we are writing it is integration over c. The value of y we have, it is 2 sin t. The value of z we have, it is 0 divided by 2 cos t. Then we have ds, and ds we can write it is ds by dt into dt, and the value of ds by dt we have, it is 2. So the answer we obtain over here, it is 2 times integration. Now what this curve c represents? We are saying we are calculating the integral from point 2 0 0 to square root 2 0, that is t is varying from 0 to pi by 4. The function we have over here, it is tan t into dt. So answer we get, this is 2 times log of secant t. 0 to pi by 4 is the limit. When you substitute this limit, you will obtain the answer as log 2. So this is the value of this line integral when we are taking the limits from this point to this point, and it is being given that it is counterclockwise direction. So that is why we are assuming the answer to be counterclockwise direction, means we are moving from 0 to pi by 4. Counterclockwise direction gives us the limit is from 0 to pi by 4. If it is being given that it is in the clockwise direction, then it will be, limit will be from pi by 4 to 0. So this is the answer in this case. Now next question we have is, for the vector field, this vector field is given to us. Calculate the value of this integral from origin to the point a1 1 1. along the path C, first case we have, it is first path that is given to us, it is x is equal to t, y is equal to t square and z is equal to t cube. So along this first path, when we are talking about the value of r vector that we have, that is equal to t I cap plus t square j cap plus t cube k cap. The value of f vector that we have, that is equal to 3t square plus 6t square, that will be 9t square I cap. Next it is minus 14t raised to the power 5 j cap plus 20t raised to the power 7 times k cap. Now we have to evaluate the value of f vector dot dr vector. So that will be equal to, when you multiply these values, you will obtain. Now first we are calculating the value of dr vector. So that is equal to I cap plus 2tj cap plus 3t square k cap. Now when we take the dot product over here, the answers we will obtain, it is 9t square. Next we will have minus 28t6 and next we will have it is plus 60t raised to the power 9. Now if we evaluate the integral, the value we have, it is integration 60t raised to the power 9 minus 28t raised to the power 6 plus 9t square into dt, and the limits of t, they are varying from, we are saying from origin to the point 111. So the value of t is varying from 0 to 1. So when we integrate this value, the answer we obtain, it is 6t raised to the power 10 minus 4t raised to the power 7 plus 3t cube. Limits are from 0 to 1. So answer we have, it is 6 minus 4 plus 3, that is equal to 5. So this is the answer we obtain in this case. Next is the straight line from origin to A. So the point, this is the point origin, this is the point A, the coordinates of A, this is 111. So this line we have the equation, it is I cap plus j cap plus k cap. So we are saying the r vector is equal to, the equation of this line, it is t into I cap plus j cap plus k cap. This is the direction and we are multiplying it with t. So we are getting the value of dr vector is equal to I cap plus j cap plus k cap. Now f vector dot dr vector, the value we have, it is 3t square minus 60 minus this is plus 60 minus 14t square plus 20t cube times dt. Now when we calculate the value of the integral over C, f vector dot dr vector, we obtain this value, it is integration 0 to 1. The value of t, it is varying from 0 to 1, and the values we have over here, it is 20t cube minus 11t square plus 6t into dt. So this is equal to 5t raised to the power 4 minus 11 by 3t cube plus 3t square, and limits we have, it is 0 to 1. So the answer we get, it is 5 minus 11 by 3 plus 3, that is equal to 13 by 3. So this is the value of line integral in this case. Now next we have to evaluate the line integral along the curve x square plus y square is equal to 1, z is equal to 1 in the positive direction from the point 0 1 1 to 1 0 1, where the value of f vector is given over here. So again, this is the equation of the circle at z is equal to 1. So we are saying the substitution we have over here, the parametric form of this circle, it is x is equal to cos t and y is equal to sin t. The value of z we have it equal to 1 and t is varying from 0 to 2 pi. So the value of f vector that we have over here, that is equal to, it is yz plus 2x I cap. So it is sin t plus 2 times cos t I cap, then it is plus cos t j cap, and then it is plus sin t cos t plus 2 times k cap. This is the value of f vector. The value of r vector that we have, it is x is cos t I cap plus sin t j cap plus z is 1, so it is k cap. So the value of dr vector we have, it is equal to minus sin t I cap plus cos t j cap. Now we have to calculate the value of f vector dot dr vector. So that is equal to minus sin t into sin t plus 2 cos t plus cos square t dt. So this is equal to cos 2t minus sin 2t into dt. We are getting from this, it is minus sin square t minus 2 sin t cos t. Now cos square t minus sin square t, we are having cos square t minus sin square t, this is equal to cos 2t, and 2 sin t cos t, it is equal to sin 2t. Now if we integrate this value, we are getting it is cos 2t minus sin 2t dt, and the limits they are varying from, we are saying these are the values. So at 0 1 0 0 1 1, we are saying cos t is equal to 0, sin t is equal to 1, and z is equal to 1 is given. So the value of t that is varying from this limit, we are saying the value of t that we have, it is pi by 2, and from the point 1 0 1, we are saying 1 is equal to cos t and 0 is equal to sin t. So we are saying that it is varying from pi by 2 to 0. So on integrating, we obtain this is equal to 1 by 2 sin 2t plus 1 by 2 cos 2t, and the limits they are varying from pi by 2 to 0. So the answer we are writing, it is, when you substitute the upper limit, you get it is 1 by 2 into 0 minus 0 plus 1 by 2 into 1 plus 1, that is equal to 1. And another method to solve this problem, it is, we are writing it is integration f vector dot dr vector integration over c. So we are writing it is equal to integration over c yz plus 2x into dx plus xz into dy plus xy plus 2z into dz. We have just done, I have calculated the value of f dot dr. Now in this particular case, this is the total derivative of, this is integration over c, this is total derivative of x y z plus x square plus z square. So that is equal to x y z plus x square plus z square, and the limits that are varying, it is from 1 0 1 to the point 0 1 1, and the answer on substituting this value you will obtain, when you will substitute the upper and lower limit in this case, the final answer you will obtain, it is 1. So it is up to you that how you want to solve these kind of problems, but in this kind of approach you should know how to calculate the total derivative over here, or you should know that the total derivative of this function is this. Only then you can apply this kind of method, otherwise it is not possible to solve these kind of integrals. Next is determine whether the line integral is independent of the path of integration. If so, then evaluate it from this point to this point. So to prove that this integral is independent of path of integration, we have to prove that the function f vector is equal to 2xyz square I cap this. Next we have plus x square z square plus z cos yz j cap, and last term we have it is plus 2x square yz plus y cos yz k cap. we have to prove that this function is irrotational, or this force, it is conservative force. So to prove this, we have to prove that the curl of f vector that is equal to 0. So we have calculated this curl over here. We are saying it is I cap, j cap, k cap. We have obtained this determinant. It is curly by curly x, curly by curly y, curly by curly z, and these are the components that we have for I, j and k. These are the components of I, j and k. Now if we calculate this determinant, we are writing corresponding to I cap. It is derivative of this term with respect to y. So answer we are getting, it is 2x square z plus cos yz plus it is minus sign over here, minus yz sin yz. This is with I cap. Then we have the partial derivative of this term with respect to z. So the answer we will obtain, it is minus 2x square z, then it is plus cos, this minus sign is there, yz, and last term we will obtain, it is minus yz sin of yz. Then we are saying with j cap minus j cap, we are having the derivative with respect to x, it is 4xyz, and then derivative with respect to z we have, it is minus, and the value we obtain from this, it is 4xyz, and last is plus k cap, and with k cap the derivative with respect to x, it is 2xz square, and then it is with minus sign, derivative with respect to y, it is 2xz square. So all these terms over here, they get cancelled. This whole I cap terms, they get cancelled. This j cap and k cap get cancelled, and the answer we obtain, it is 0. So we have proved that this f vector is irrotational. That is integration, the closed integral over the curve C, f vector dot dr vector is independent of the path of integration. Now to evaluate this integral, we are saying we are integrating over C f vector dot dr vector. We are having this whole function, talking about this whole function, and we have this function is the total derivative of this term. We are saying this is equal to integration from a to b. It is independent of path. We have to integrate between these 2 points. It is a to b d of x square yz square plus sine of yz. Now how to calculate these values? For this you can refer the video related to the total derivatives, or this is the potential function we are saying. This is the potential function. If f vector is irrotational, then this will be the potential function corresponding to f vector. And if we substitute these values over here, we are saying the integral, it will become x square yz square plus sine of yz, and the limits that are given over here, they are varying from the point 1 0 1 to the point 0 pi by 2 and 1. So if you substitute these limits, you will obtain the final answer as 1. This is the final answer in this case. Now suppose we are not able to find the total derivative over here or the potential function, then there is another approach that we can use. We are being given 2 points. One is the point 1 0 1, and the other point we have, it is 0 pi by 2 and 1. Suppose we are saying we have some curve which is from this point A to point B, and we have proved that the function that is given to us, f vector, it is the integral that we have, it is independent of the path. So in place of choosing a particular path, we have divided this path in 2 regions. We are saying we are moving from point say A to A dash and then A dash to B. This A point we have, it is 1, 0, 1, and this point it is 0, pi by 2 and 1. 0, pi by 2 and 1. Now we are moving from point A to A dash, where A dash is the point 0, 0, 1. Now, and we are saying we are moving along a straight line. Now for this straight line, what we have is that the value of y we have, it is 0, and the value of z we have, it is 1. Both these values, these are fixed, and the value of x is varying from 0 to 1. We are saying on this line we have the value of y is 0, we have the value of z is 1, and x is varying from 0 to 1. Then we are moving from A dash to B, and on this A dash we are saying x is equal to 0, we have z is equal to 1, and y is varying from 0 to pi by 2. So what we obtain is, we have, this is the value of integration of f dot dr vector. This is on this whole, this is from, we have to calculate the value from moving from A to B, but this value is independent of path. This thing we have proved. So we have chosen another path. We are saying it is moving from A to A dash and then A dash to B. So when it is moving from A to A dash, we are saying when it is moving from A to A dash, this integral will become the value of y is 0, z is 1. In this we will substitute y is 0, z is 1. This term will become 0. When we substitute y is 0 and z is 1, then dy is 0 and dz is 0. So the net value we have, it is equal to 0 times integration of 0, that is equal to 0. We are saying while moving from A to A dash, the net value of this integral, it is 0. And then we are moving from A dash to B. When we are moving from A dash to B, we are saying the value of this integral will become, now in this case we are having y, x is 0 and z is 1. It means we are, this first term dx is, there is no change in x, there is no change in z, so dz is also 0. We are left with this term, and in this term when we substitute x is equal to 0 and z is equal to 1, we are getting the answer, it is cos y dy, and y is varying from 0 to pi by 2. So when you substitute this limit, you will obtain it is sin y, limit is from 0 to pi by 2, and the answer we obtain, it is equal to 1. So you can use this method to calculate the integral in this case. Next is prove that this f vector is given. It is a conservative field. We have to calculate the scalar potential, and then we have to find the work done in moving an object in this field from the point P1 to P2. So to prove that it is conservative field, it means we are talking about, we have to prove that curl of f vector is equal to 0. So these calculations, these are shown over here. We have calculated the curl. This is I, j, k. These are the components of f vector. So when you will open this determinant, you will obtain the value in this form, and the answer you will obtain, that is equal to 0 vector. So we are saying that the curl of this vector is equal to 0. That is this field, this f vector, this is a conservative field. Now we have to calculate the scalar potential over here. So we are writing f vector, that is equal to y square cos x plus z cube I cap plus 2y sin x minus 4 times j cap plus 3xz square plus 2 times k cap, and we are writing this is equal to curly by curly x phi, this is I cap, plus curly phi by curly x j cap plus curly phi by curly z k cap. So we obtain curly phi by curly x is equal to y square cos x plus z cube. So from this we can say that the value of y we have that is equal to y square sin x plus z cube x. Similarly, from the second term, when we are equating curly phi by curly y is equal to this, we are saying the value of phi that we can have, it is 2y square by 2 into sin x minus 4y. And from this third term, we are saying the value of phi that we have, that is equal to, on solving this value we will obtain it is xz cube plus 2z. So from these terms we are saying that the potential function phi, if we are calculating the total derivative, we are having the term y square sin x plus xz cube minus 4y plus 2z. This procedure we are saying, this is not any standard procedure to calculate the values. For the standard procedure you can refer to the video related to the potential functions. We are saying this is not standard procedure, but just to find the answer you can calculate the values of phi and you can find the total derivative in this term, so that we can obtain, this is the value of d phi, so we are writing that the value of phi we have that is equal to y square sin x plus xz cube minus 4y plus 2z plus c. You can see it is y square sin z, then it is z cube y, z cube x, and then we have these two terms, it is 2z and minus 4y. This is not the standard procedure. I am again repeating this thing. This is not the standard procedure to calculate the total derivative. But just to find the answer over here, we are using this procedure. So we are saying that the potential function, the required potential function, it is in scalar potential we have, it is this. Now we have to calculate the value of the work done in moving the point from the point P1 to P2. It means we have the value, it is phi at P2 minus phi at P1. So if you substitute these values you will get the answer, it is 1 plus 8 into pi by 2. We are substituting the value over here. Then it is plus 4 plus c minus 0 plus 0 minus 4 minus 2 plus c. So the answer we obtain that is equal to 4 pi plus 15 units. Answer we obtain it is 4 pi plus 15 units. Now next we have is a vector field is given by this formula. Show that the field is irrotational and find its scalar potential, and hence evaluate the line integral from the point 1 2 to 1. So first of all, to prove that it is irrotational field, we have written I, j, k. We have taken the partial derivatives over here, curly by curly x, curly by curly y, curly by curly z. These are the components of f vector, and when you solve this you will obtain the answer as 0 vector. So we are saying that the field f vector is irrotational. So suppose we are saying that there is a scalar potential phi that will exist because it is a conservative force, or we are saying f vector is irrotational. So what we obtain is that f vector that is equal to del phi. So from this what we obtain is that the value of d phi that we have, it is equal to x square minus y square plus x dx plus it is minus sign over here, minus 2xy plus y into dy. Now it is minus sign over here. So we can write d phi is equal to x square dx, then we have plus x dx minus y dy then it is minus y square dx, and then it is minus 2xy dy, and we are writing this is equal to dx cube by 3 plus dx square by 2 minus dy square by 2, and then this time it is minus sign common, this is d of y square x. So we are writing the value of phi, we have it is equal to x cube by 3 minus xy square plus 1 by 2 x square minus 1 by 2 y square plus c. So this is the value of the potential in this case. Now in the last part, we have to evaluate the line integral from the point 1 to 1. We are calculating the value of integration f dot dr, and it is from the point A to B. So the answer we have it is phi b minus phi a. So that is equal to, when we substitute the value of b, that is 2 comma 1, this is the point 2 comma 1, and this is the point 1 comma 2. When we substitute these values over here, the answer we obtain it is 8 by 3 minus 2 plus 2 minus 1 by 2 plus c minus 1 by 3 minus 4 plus 1 by 2 minus 2 plus c. So the answer, the final answer we obtain in this case, it is equal to 8 by 3 minus 1 by 2 minus 1 by 3 plus 4 minus 1 by 2 plus 2, that is equal to 22 by 3. So this is the value of the line integral from 1 comma 2 to 2 comma 1. Next we have is, find the work done in moving a particle once around the circle x square plus y square is equal to 9 in the xy plane if the force is given by this, and if possible find its scalar potential. So this circle is given. So in parametric form, this equation of this will be given by x is equal to 3 cos t, y is equal to 3 sin t, and the value of z we have it is xy plane, it is 0, and t is varying from 0 is less than equal to t is less than 2 pi. So the value of r we have it is 3 cos t I cap plus 3 sin t j cap. So the value of dr we have it is equal to minus 3 sin t I cap plus 3 cos t j cap into dt. This is the value of dr we have, and the value of f vector we have, when we make this substitution, the value of f vector we have, it is 6 cos t minus 3 sin t into I cap, then it is plus 3 cos t plus 3 sin t into j cap, and then it is plus 9 cos t minus 6 sin t into k cap. Now if we calculate the value of f vector dot dr vector, we obtain this is equal to, we are taking the dot product over here, so there is no k term over here, so this term will become 0, and when you multiply these terms you will obtain the answer as minus 3 sin t into 6 cos t minus 3 sin t, then it is plus 3 cos t into 3 cos t plus 3 sin t and whole dt, and this value comes out to be 9 minus 9 by 2 sin 2t into dt. Now if we integrate these values about the closed curve, that is we are varying it from 0 to 2 pi, the answer we obtain that is equal to 9t plus 9 by 4 times cos 2t. Limit is varying from 0 to 2 pi, so the answer we get it is 18 pi. Answer we obtain that is equal to 18 pi. So what we can see from here is that the integration about the closed curve f dot dr vector, this is equal to 18 pi. It means that the work done along the closed curve is not equal to 0, and this implies us that the field f vector is not, the force f vector is not conservative, And if it is not conservative, so it is not possible to find the, so this implies that scalar potential does not exist. This implies us that the scalar potential in this case, it does not exist. Next we have is find the work done in moving a particle in a force field. This is the force field given along the curve x is equal to t square plus 1, y is equal to 2t square, z is equal to t cube, and t is varying from 0 to 2. So the value of r that we have, it is t square plus 1 I cap plus 2t square j cap plus t cube times k cap. So the value of dr vector we have, it is 2t I cap plus 4t j cap plus 3t square k cap times dt. Now if we calculate the value of f vector, if we calculate the value of f vector dot dr vector, the answer we obtain, the f vector we have, it is 3 into t square plus 1 into 2t square I cap minus 5t cube times j cap, and it is plus t square plus 1 10 k cap. Now if we take the dot product of these two and we open these terms, we obtain, we are taking the dot product of these terms with dr, and when we open all these terms, we obtain it is 12t raised to the power 5 plus 10t raised to the power 4 plus 12t cube plus 30t square into dt. Now if we integrate these values, we are integrating these values from t is equal to 0 to 2. Integrate this value from 0 to 2, t is varying from 0 to 2. So the answer we obtain, that is equal to, on integrating this, it is 12t by 6, so it is 2t raised to the power 6 plus this is 10t raised to the power 5 by 5, so it is 2t raised to the power 5 plus this is 3t raised to the power 4 plus 10t cube. Limits are varying from 0 to 2. So the answer we obtain, it is 128 plus 64 plus 48 plus 80. So value we obtain, it is 320 units. So the value we obtain in this case, it is 320 units. Next is, if f vector is equal to this, displaces a particle in xy plane along the curve y is equal to 4x square, and it is moving from this point to this point, then we have to calculate the work done. So we are saying the value of r vector we have, it is equal to x I cap plus y j cap. If we substitute this value of y over here, because it is moving along this curve, we obtain this is equal to x I cap plus 4x square times j cap. So the value of dr vector we have, it is I cap plus 8x j cap into dx, it is derivative with respect to x. Now the value of f vector that we will have, the value of f vector we have, it is 2x square. In place of y we are substituting 4x square I cap plus 3x into 4x square j cap. So this value we have, it is equal to 8x raised to the power 4 plus 12x raised to the power, this is I cap and this is j cap. Now f vector dot dr vector, that is equal to, if we take the dot product over here, we get it is 8x raised to the power 4 plus 96x raised to the power 4, that is equal to 104x raised to the power 4 times dx. Now we have to integrate f vector dot dr vector, and the value of x is varying from 0 to 1. The value of x, it is varying from 0 to 1. This, in place of dr we can write it as dx now, or we leave dr over here and we are getting, this is the point P2, q. So we are getting it is integration 0 to 1, 104x raised to the power 4 into dx. So this is 104 by 5, x raised to the power 5, and limit is from 0 to 1. So the answer we obtain it is 104 by 5 units. So this is the answer, or this is the value of this integral. Now next we have is find the work done by the force F vector is equal to this in displacing the particle along the triangle OAB, where the sides of the triangle they are given by, these are the sides, we are saying OA, OB and BO. So we are first calculating the value of F dot dr vector, that we have it is x dx minus z dy plus 2y dz. Now when we are talking about this first line, we are talking about OA. On this line we have y is equal to x, z is equal to 0. So if we have y is equal to x, this implies us that dy is equal to dx and dz is equal to 0, because z is equal to 0 is given. So if we integrate along the line from the point O to A, F vector dot dr vector, we are saying the answer we obtain that is equal to integration from 0 to 1, because x is varying from 0 to 1 and x is equal to y. We have substituted in this equation, in place of y we are substituting it is x, that is 0. So we are left with this x dx, both of these terms will become 0. Now when we are integrating, we have reached the point A, now we are moving towards the point B, we are calculating the value of f dot dr vector. Now along AB we have x is equal to 1, y is equal to 1 and z is varying. It means we have dx is equal to 0, we have dy is equal to 0. So we are left with this 2 dz, and the limit of z that we have in this case, it is varying from the value of z, it is varying from 0 to 1. Now we have reached the point B. Now we are moving from B to the point O and we are writing it is f vector dot dr vector, and on this line BO we have x is equal to y is equal to z. So dx is equal to dy is equal to dx. All these values, these are equal. So we obtain this is x dx minus x dx plus 2x dx, and this value it comes out to be equal to, these two gets cancelled, it is integration x dx. Now the limits for this, it is moving from B to O. Now corresponding to the point B, the value of x that we have it is 1 and at O it is 0. So we are saying the limit we have it is 1 to 0. Now if we evaluate all these limits, the first answer we obtain that is equal to 1 by 2. In this case the limit we obtain it is equal to 2, and in this case when you substitute this limit, it is x square by 2 gets cancelled and we are left with is minus 1. So we are saying that the work done, that is integration OA plus integration AB plus integration BO, that is equal to, we are saying the sum of all these values, it is 1 by 2 plus 2 minus 1. So answer we have it is 3 by 2 units. So this is the total work done in displacing the particle along the triangle OAB. Next we have is, if f vector is equal to this, calculate the circulation of f vector along the circle in the xy plane of radius 2 and center at the origin. So we are saying the circle that is given to us, it is x square plus y square is equal to 4. So in parametric form the equation is x is equal to 2 cos t, y is equal to 2 sin t, it is in the xy plane. So z is equal to 0, value of t is varying from 0 to 2 pi. Now the value of dr that we have, dr vector, that will be equal to minus 2 sin t I cap plus 2 cos t j cap into dr, or we are writing it as dt. Now if we calculate the value of f vector dot dr vector, the answer we have it is minus 8 sin t cos t plus 4 sin square t plus 4 cos square t plus 4 sin t cos t into dt. Now if we are calculating the circulation over here, we are saying we are calculating the closed integral. The value of t, it is varying from 0 to 2 pi, and if we integrate this value, we are getting it is 0 to 2 pi 4 minus 2 sin 2t into dt. This is equal to 4t plus cos 2t. Limit we have it is 0 to 2 pi. So the answer we obtain it is 8 pi units. So this is the circulation of this f vector along the circle of radius 2 in the xy plane.